Hello everyone and welcome to object detection using AI and deep learning. So in this tutorial we'll be taking support of opencv and Python and using Raspberry Pi. I'm using presently Raspberry Pi 4. You can go ahead with Raspberry Pi 3 also. So there will be absolutely the difference in performance regarding speed and quality, video qualities, because the processors are different in speed. So focusing on our tutorial to in this session, this time we will be detecting persons, the human body, in a given video. So let's get started. Go to programming, Genie. Okay, we have got a program here which detects pedestrian wa walking along particular path. So in this video, I'm in this particular tutorial, I'm using video taken from a random pickup point where people walk through. So our program will be detecting the persons and highlighting them using a rectangle. So as we have seen in previous tutorials, we are using some hard cascade algorithms and cascade classifier functions that is used to detect particular object. So this has to detect any object, it has to be trained first using several training sessions. Like it should first extract features of the object. For example, we are detecting a person. What are the features? It identifies those features. While training, it gets understood that this object has particular features. So for example, I'll be taking a face, hands, legs, of face which includes head, okay, and when it walks it has different angles of posture of hands and legs also. So this posture is trained and it saves as a features. So these features are classified as vectors, and this is stored in .xml file, hard cascade full body.xml. So this file includes those features, all right, which has to be applied to cascade classifier. So cascade classifier, it has built-in algorithm which applies to this file and tries to extract those features, and then later on we'll be using one more function, that is detect multi-scale function, where it takes gray form of the image and applies those objects, and it returns those detected objects in the particular image, and it is stored in person detected variable. So let's see step by step. So I'm importing here import cv2 computer vision package opencv, and then I'm also including importing numpy numerical python package and denoting it as np, and then I'm using a cascade classifier function which has algorithms as already discussed. It is defined in opencv2 cv2 library package, and I have to give it as an argument the file name harcascade fullbody.xml. This file is defined in cv2. So cv2 opencv library package has lot of pre-trained objects, and full body human body is one of them. All right, so I'm just giving the file name here because it is stored in our current directory, and we need not give its path, otherwise we have to apply the path also location. All right, and then what I'm doing is I'm capturing a video feed I have taken from a I have randomly picked it up from a public video, and I'm giving it as an input argument to video capture function, and that is defined in CV2, right? Then this returns in a variable capture. So this returns a video file and is stored in capture. Okay, now I'm putting it in while loop. The while loop continuously executes the video and its functions as long as this video capture, this video file is being running, after which it breaks the loop and goes out of the loops and exits the program. So this while loop runs as long as the video is running. Okay, and in first function in while loop, I'm capturing the images, because we are going to work on images rather than video. So in video I'm going to capture images. So capture.read, I'm getting image file and storing it in frame variable and at the same time ret variable. All right, and then this is just a extra line, I'm not ignoring it because I don't need it right now. And then I'm going to use function detect multiscale, and this function has an input image file that is in gray form, gray image scale. So I have to convert it into gray space model, color model. So for that I am to use cvt color function defined in cv2 that we have already seen in image processing tutorials. And then it takes frame as an input, and this is the code which converts BGR color space model to gray space model, and then it is stored in gray variable. Before that, what we are doing is we are going to resize the image, because we want that image to be resized and reduced to a particular size, instead of capturing the and using the original size, but we want that image to be reduced and resized to our own custom. So here I'm using a function cv2.resize, and this takes frame image variable image input image file as an argument, and then I'm using fx and fy as the coordinate the size along x-axis, the horizontal width, and it is good fy is the vertical width, and this is the code. This is the size, the final size which it is going to be projected finally. So interlinear is what model we want after resizing the image, and it has a lot of options here also, like intercubic and inter area. So interpolation, there's a lot of forms of interpolation. So right now here we are using interlinear. Okay, let's go ahead. So right here, person detect, we have got this person detect variable as a result of this cascade classifier function, and then in that we are using detect multiscale function, which takes gray scale form of the input image, and this is scale factor. This scale factor is used is the factor which we want that particular object to be reduced to so and so size. So what does this detect multiscale function does? It extracts those objects present in person detect. So in person detect we have got those person objects, and that is what cascade classifier is doing. It is returning the detected objects in an image. So those objects here presently we have is person, so those object is stored in person detect variable, and from person detect variable it is going to outline those images, those objects with this scale factor 1.2. It is going to reduce that outline to 1.2, and this is what the thickness is. All right, but and min size, max size are also part of the argument list of detect multiscale, but they are optional, we can ignore that. All right, so you can check here the syntax of cascade classifier dot detect multiscale function. This is input image, this is scale factor, and minimum neighbors that are to be included in that rectangle of the object, and flags are minimum size and maximum size. The minimum object size we want to include, beyond which we will ignore those smaller objects than this size, given size, and this is the maximum size beyond which we want to ignore the objects larger than this size. Presently we can ignore it and go ahead. All right, so what happens here, after this function is executed, we have got those rectangular objects with a rectangular outline. What we are going to do is we are going to draw rectangle with the function cv2.rectangle, and that is defined in for loop, and x, y, w, h are the size, width, height, and horizontal and vertical stretch, okay, of the rectangle. That in is a keyword, as we've already discussed in for loop tutorials. In person detected is what here we have got, and then this we are executing this rectangle function. We want to draw the rectangle on each object, and this is a frame is the input image we are going to work upon. X, y are the coordinates, x plus y are the width, x plus w is the width, y plus h is the height, and then this is the color we want to define. BGR means it's going to be red, so pure red we are going to use because blue and green are 0 here, and red is the color, full color we want to define, and this is the thickness of the rectangle. And then we are going to show each image using I am show function. This is still we are still in the for loop, and I am show function is used to display that resultant image, okay, you've got from this rectangle, and we are putting it frame. All right, and then in this image, in this function, during this function we are going to get each image with the highlighted objects we are looking for, that is persons here, and then this function will be used to wait from which waits from the user to get escape character sequence, and then it breaks out of the loop, and that is a while loop we are still in. And after this it is going to release the video capture is going to release, and then after which it's going to destroy all windows using destroy all windows function, and after that it's going to exit the program. Okay, so let's go to build and execute and check what we get here. All right, it's executing. Okay, this is what the pedestrian detection video we are here, and you can see it is highlighting each person here, and the rectangle what we have seen just now, the function, it is highlighting each person here. So we can check the speed, and we can see how the program is working and detecting random persons here. It is able to detect the persons in a video I've taken from the internet probably. Okay, so we can exit this right now. So this program is working as according to our inputs and functions we are using here. So we are able, in this program we are able to detect a person using cascade classifier algorithm and hard cascade full body.xml file, which is already which has trained features defined in opencv package. So with this I hope it's enough to get started, and you can try your own, and you can change the input file, and you can even go ahead and use the live capture and just project your camera to the outside world. Maybe you can detect also. So happy programming. Go ahead and try it out. See you later in next session.